Course 3, Lesson 117, we'll go through significant digits. So significant digits are the number of digits that we use to express a measure with confidence. So for example, the measurement 8.9 centimeters is two significant digits. We have 8 and 9. While we are counting significant digits, there are 6 rules that we need to follow. The first one is that we need to count all non-zero digits. So for example, we have 2.54. This has 3 significant digits. We have 1, 2, and 3. The second rule is that we need to count zeros between non-zero digits. So for example, we have 10.7. This also has 3 significant digits. We have 1, 2, and 3. We are still counting this 0 because it is between 2 non-zero digits. The third rule is that we count trailing zeros in a decimal number. So we have the decimal 1.20. So this also has 3 significant digits. Rule number 4 is that we do not count zeros if there is a non-zero digit to the left. So for example, the number 0.023 only has 2 significant digits because we are only counting these 2 numbers. We are not counting the numbers to the left since they are zeros. The fifth rule is that trailing zeros of whole numbers are ambiguous. So the number of significant digits in 1200 might be 2, 3, or 4. So expressing a number in scientific notation removes this ambiguity. So the number 1200 we had. So if we write it in scientific notation, you have 1.20 times 10 to the third. This has 3 significant digits. 1, 2, 3. The last rule is that exact numbers have an unlimited number of significant figures, so we do not count any digits when dealing with exact numbers. So exact numbers include counts and exact conversion rates like 3 feet per yard or 2.54 centimeters per inch. So for exact numbers, we will say that they are unlimited. So for example 1, we are going to state the number of significant digits in A, B, C, and D. So if we look at A, we have the diameter of a quarter is about 2.5 centimeters. So here we are going to just count our non-zero digits. So we have 1, 2. So this is 2 significant digits. For B, a ruler is about 30.5 centimeters long. For this will be 3 significant digits because we are still counting this 0 because it is between 2 non-zero digits. For C, Earth's average distance from the sun is about 9.3 times 10 to the 7th miles. So for this, we are just going to continue counting the non-zero digits. So we have 1 and 2. For D, we have a mile is 5,280 feet. So for this is an exact number. So this means that it can have an unlimited number of significant figures. So this answer will be unlimited because it is exact. When performing calculations with measures, scientists need to be careful to not include more digits in the results than are justified. So we want to follow this rule to determine the correct number of significant digits when we multiply and divide. The rule is that a product or quotient of 2 measurements may only have as many significant digits as the measurement with the least number of significant digits. So, for example 2, it is asking if the segment at the beginning of the lesson is divided into 4 equal segments, what would be the length of each segment? So at the beginning of the lesson, the segment was 8.9 centimeters long. So we want to divide it into 4 parts. So we'll just divide by 4. And then after you do your division, you will get 2.225. The number 4, as we talked about in the previous example, this is an exact number. So this number does not affect the count of significant digits. However, when we look at 8.9, we know that this has 2 significant digits because we are counting the non-zero digits. So we know that the quotient then should have no more than 2 significant digits. So then we will round the quotient to 2 significant digits. So we will take this and round it to 2 significant digits, giving us 2.2 centimeters long as our answer. For example 3, we are asked what is the volume of a cube with edges 1.2 millimeters long. So in order to figure this out, we calculate the volume by finding the cube of the length of the edge. So we have the volume equals 1.2 millimeters cubed. So once you do your math, you will get the answer 1.728 millimeters cubed. Now we have to figure out how many significant digits our answer needs. So we have our number here, 1.2. We are going to count the non-zero digits, so that will give us 1 and 2. So we have 2 significant digits. So this means that our answer will have 2 significant digits as well. So we will round 1.728 and we will get 1.7 millimeters cubed. So we also want to follow this rule to determine the correct number of significant digits when we add and subtract. So a sum or difference may show no more decimal places than the measurement with the fewest number of decimal places. So for example 4, the problem is the test tube contained 6.24 milliliters of liquid before it was heated and 4.6 milliliters after it was heated. How many milliliters of liquid evaporated when the test tube was heated? So all we're doing is subtracting 4.6 from 6.24. So after you do your math, you will get 1.64 as your answer. However, we need to look at these two numbers. So we have 6.24 and we have 4.6. So if we remember this rule, the sum or difference may show no more decimal places than the measurement with the fewest number of decimal places. And the number with the fewest number of decimal places is 4.6. So if we count this, we have 1, 2. So we have 2 significant digits in this number, meaning that our answer can have no more than 2 significant digits as well. So once we round this, we will get 1.6 milliliters of liquid evaporated as our final answer.